Hey guys, today we are going to practice finding trig values on a circle, and sometimes we're going to use a true unit circle and sometimes we will use special right triangles on a circle. Now before we start, let's review 30, 60, 90 triangles. So here is a 30, 60, 90 triangle, and on a 30, 60, 90 triangle we need to remember that the shortest side will be 1, the longest side, the hypotenuse, will be 2, and the remaining side is the square root of 3, which is about 1.7, so that's the medium side. Okay, but always remember the shortest is 1, the longest, the hypotenuse, is 2, and then the remaining side, the medium side, the longer leg, is the square root of 3. And in a 45, 45, 90, it looks about like this. And that comes in the ratio 1, 1, square root of 2. Okay, now we're just going to do a handful of problems from this worksheet together. In fact, we're going to turn over to page 2 right now. And we're going to do number 15 first. So number 15 is secant 240 degrees. So I will draw a triangle. Okay, and then put in my x and y axis. And 240 degrees, if we rotate all the way to here, we're at 270, so we're going to be a little bit short of that. So 240 degrees goes right about there. Okay, now we need to find the reference angle measure right there. So to find the reference angle, we can do 240 minus 180, and that is 60 degrees. So right here, I have a 30, 60, 90 triangle. Okay, so on a 30, 60, 90, our numbers are shortest leg 1, the hypotenuse 2, and the long leg square root of 3. Okay, now this hypotenuse, that is the radius. That's always a positive number. This short leg, though, this goes to the left. That's got to be negative. And this longer leg is down. That is negative. So x and y can be negative, but remember the hypotenuse, the radius, is always a positive number. So we are looking for secant. Secant is reciprocal of cosine, so it's hypotenuse over adjacent. Hypotenuse is the radius. Adjacent is the x value. So secant is always r over x. So that is 2 over negative 1, which is negative 2. Okay, next we'll do number 16, sine of negative 45 degrees. So here is our circle with our x and y axis. Negative 45 degrees, that means it rotates clockwise 45 degrees to right about there. So we have a 45, 45, 90, which comes in the ratio 1, 1, square root of 2. Okay, this 1 is to the right, that's positive. This 1 is down, that's negative. And the square root of 2 is the radius, that's always positive. Sine is opposite over hypotenuse, or y over r. Okay, so that's negative 1 over the square root of 2. Now we need to multiply top and bottom both by square root of 2, so that's negative root 2 over 2. Okay, let's go down to number 18, sine 360. So that, on our circle, rotates all the way around to here. Okay, so it looks like that. Okay, now, this is a case where I would use a true unit circle. So we'll just make this point right here 1, 0, and say the radius is 1. Okay, so sine is y over r. The y value is 0, the radius is 1, so we get 0 for our sine. Number 19. If tangent theta is 11 over 3, find sine theta. Okay, so let's draw a triangle. And tangent is opposite over adjacent, so that's 11 over 3. Okay, so we'll do the Pythagorean theorem to find the hypotenuse, so we can do sine. So that's 11 squared plus 3 squared equals c squared. So that's 121 plus 9, so that's 130 equals c squared. Okay, now the value of c is the square root of 130. Can that be simplified? So 130 is 13 times 10. And 10 is 5 times 2, so this is the same as the square root of 13 times 5 times 2, and I have no square numbers in there. So the square root of 130 cannot be simplified any further. Okay, so sine theta, opposite over hypotenuse, is 11 over the square root of 130. Now we multiply top and bottom by the square root of 130, so we get sine theta equals 11 times the square root of 130 over 130. Okay, now something important to learn is that sine, we know sine theta is opposite over hypotenuse, but we need to remember that in a circle, opposite comes from the y value, hypotenuse comes from the radius. Cosine theta is adjacent over hypotenuse, and we need to remember that adjacent comes from the x value, and the hypotenuse is the radius. And tangent theta is opposite over adjacent, and we need to remember that opposite comes from the y value, and adjacent comes from the x value. So we'll go ahead and finish this lesson with some review now. So given angle theta in standard position, if a point with the given coordinates lies on its terminal side, find secant theta. Okay, so this point, negative 3, 4, lies on the terminal side. In standard position, our angle starts here at the positive x-axis and rotates this way. And there is our terminal side, and it includes negative 3, 4. We need to use the reference angle, which goes from the terminal side to the nearest x-axis. So that angle theta is our reference angle. Okay, so we'll make a right triangle out of that. And our x value is negative 3. Our y value is 4. And we're going to find secant. Secant is reciprocal of cosine. So secant theta is hypotenuse over adjacent, reciprocal of cosine. So we need to know the hypotenuse. Okay, now on this triangle here, on this circle, the hypotenuse is the radius, the adjacent is the x value. Okay, so we need this radius or hypotenuse. So we can do negative 3 squared plus 4 squared equals c squared. That's 9 plus 16, that's 25, equals c squared. So c is 5. Okay, now I hope you could recognize that. It's a very common Pythagorean triple, even with negatives, 3, 4, 5. And this hypotenuse, the radius, will always be a positive number. Okay, so secant theta is the radius over the x value. That's 5 over negative 3. Okay, now here, the terminal side has to include negative 17, 0, so it's right here along this negative x-axis. Okay, so it rotated all the way to that x-axis, so we cannot make a right triangle out of it, but we already know secant is hypotenuse over adjacent, and hypotenuse comes from the radius, adjacent comes from the x value. Okay, so secant theta is the radius over the x value. So here, secant theta is a radius of 17 and an x value of negative 17. Remember, the radius is always a positive number. Okay, so secant theta equals negative 1. And last, if cosecant theta is the square root of 41 over 5, find tangent theta. So let's draw a right triangle, and I'll put theta right here. Cosecant is the reciprocal of sine, so cosecant theta is equal to the hypotenuse over the opposite. Okay, so the hypotenuse is the square root of 41. The opposite is 5. And for tangent, we need opposite over adjacent. So we need to find this adjacent length. So 5 squared plus b squared is the square root of 41 squared. So b squared, and I'll move this 5 squared over to the other side, is 41 minus 25. Okay, 41 minus 25 is 16, so b is the square root of 16, which is 4. So tangent theta is 5 over 4.